already finished on this MSI device, okay, which is by using a buffer in order to increase or in order to expand the number of input in our ATmega 32. Okay, and this is okay, and then this is the way lah, okay, in order to use that buffer, okay, in order to what we call here, if we want to read 16 switches, okay, we have a 16 switches, the 16 switches that are connected to port B. Okay, so how to do that? Because port B only consists of 8 bit. Since we have 16 switches, what we're going to do is we need to use a buffer. Okay, you need to have two buffers, one buffer for 8 switches and the second buffer for another 8 switches. Okay, and then you connect this switch to this buffer. Okay, and the input of this buffer is coming from the okay, the input is coming from the switch while the output of the buffer is go to your port B. Similar to the second buffer, input is coming from the another 8 switches and the output is goes to your port B. And in the meantime, okay, this buffer has a one control unit, okay, which is this control unit is used to select which buffer that we are going to read the input first. Is it a first buffer or the second buffer? Okay, if you can see, this is the control unit of the buffer. Okay, so to enable this buffer, what you're going to do is you need to give 0 to the buffer, okay, to enable, and give 1 to disable. Okay, so sorry lah. Okay, so this one here, okay, so please make the correction, yeah. To enable, okay, you're going to need to give 0. Why I say is give, why I say that we need to give 0, okay, according to this circuit here, you see this circuit here, okay, you see the pin number 1 and pin number 19. Okay, so this is pin number 1 and pin number 19. Okay, pin number 19, this pin here is always connected to ground. Okay, so this is goes to ground, which is logic 0. And then if you use put 1 here, what happened here? 0, okay, you have a bubble. After the bubble, you will get 1, and 1 bubble here, it produce input 0. 1 and with 0, it will produce 0, which is the output will always 0 lah, which is wrong lah. Okay, so what happened here is, in order to enable the buffer, you need to give 0. When this 0 go to this bubble, it will produce 1, 1, 1, and automatically the buffer will turn on, will be enabled. So please make correction ya kat sini. Okay, so to enable, okay, put 0 put 0 to enable, while put 1 to disable. Okay, kat sini. The value that you're going to put to your port C, okay, please make sure that 0 enable, 1 is disabled. Okay, in the previous class, okay, I put it wrong. Okay, which is I put 0 to disable and 1 is to enable. All right, so moving forward to the next slide. Okay, so we have the PISO. Okay, so the PISO is actually a parallel in serial out input. Okay, the what we call it, the IC for the PISO is 74LS165. Okay, this PISO here is used to save number of input pin into microcontroller. Okay, means that this is another way lah to expand the inputs, okay, the input ports in your microcontroller. Okay, for this PISO, it has two control pins. Okay, one data input into microcontroller and total of 3 pins. Okay, so this is the pin 0 and pin 1. Okay, so this is your control. Okay, you have this input here. Sorry. Okay, so this is the control input, pin 0 and pin 1. While pin 2 is the output that you need to connect to your ports. Okay, so you have you have 8 inputs coming here and 1 output, okay, and 2 control inputs. Okay, so this is okay, so you have all of the switches. Okay, you don't need to connect to this uh inputs here. All right. Oh, sorry, not this input. Input is here. This is not input. This is the clock. Okay, to select either you're going to do a preset or clears. Okay, so where is the input? Shift log clocks, and let me see where is the input coming from. Yeah, this one. Okay, sorry. Here is the input A, B, C, D, E, F, G, and H. Okay, so you have a parallel of data coming in. Okay, so in this case, 8-bit data coming in, and meanwhile, only 1 output will go to your ports. Okay, so it will shifted 1 by 1 until it is finished. Okay, 8-bit data is read to your ports. Okay, so this is what the PISO do lah. Okay, and then next we have the latch and level. Okay, so this latch here, you have 2 type of latch actually. Okay, which is a level trigger and edge trigger. Okay, so this latch here used to store data by the level trigger. So every time the level is triggered, either is a level 0 or level 1, and the data will be stored to the latch. Okay, so it is used to increase number of output pins. Okay, so in order to increase the output, what you're going to do is you need to use a latch. Okay, input we use the buffer, but output we use the latch. Okay, and this latch here has 1 control pin. Okay, so this pin similar to buffer, which is used to control either you're going to enable it or to disable it. All right, so this is your latch. Okay, for the latch, you can use the DM74LS373. Okay, so this is the enable. Again, if you can see here, the enable here is active low lah. Sorry, this is if you okay. So and this is a control unit. Okay, so control unit is active low. All right, and this is your input, and this is the output of the latch. So input, output, input, output. Okay, similar to this one. Okay, so this is for the latch level trigger, and there is another latch called an edge trigger. Okay, similar to the previous latch, but this latch only store data by edge trigger. Either it is a low falling edge or rising edge. For every falling edge, it will store the data. Or if you use the rising edge, so every rising edge, it will store the data. Okay, and the function here is similar, which is going to increase the number of outputs pin, and it has 1 control pin as well. Okay, so this is the pin to enable. You can see here. Okay, so this is an active low pin, means that you need to give 0, and then it will be enabled. And this is your clock pin. Okay, so your input will come in from here lah, ke atas ni, and the output of the latch will go to here. Okay, so this output of the latch will go to your ports to increase the number of output ports inside of your microcontroller or Atmega 32. Okay, and then we have the SIPO, okay, which is a serial in parallel out. Okay, so the chip that you can use for the serial in parallel out is 74LS195. Okay, and this one here used to store data by edge triggered. So store data again is to increase the number of output lah. So increase number of output pin from your micro P, and it has 2 control pin. Okay, so you can see here. Where is the control pin? I cannot see clearly this figure here. Can I see? Control pin. Okay, cannot see very clearly where is the control pin. Okay, never mind. Okay, and then so what happened here is you have a serial input. Okay, so the input is go to your this what we call this device here serially, but it will produce a parallel output. So that's why you see here you have a 8 output at this component here. Okay, one input produce several outputs. Okay, so let's look at let's look at the example. Okay, how to increase the number of input, output by using the latch. All right. So here in this example here, you are going to increase the number of output pin of port B from 8 to 16. Okay, so this is a port B. Okay, you have a PB0, PB1, PB2, 3, 4, 5, 6, and 7. Okay, theoretically, for port B0, for port B, okay, you can connect to 8 output at one time. But now, okay, you're going to expand it so that port B must connect to 16 output or 16 LED at the same time. So how to do that? Okay, to do that, okay, you need to have 2 latch, right? So this is the first latch and this is your second latch. Okay, the input of this latch, okay, will go to this uh, PB0 until PB7. Okay. Okay, the rest you just draw the circuits. And similar to latch 2, okay, the input here, okay, so this is a I0, I1, I2, I7. So similar I0, I2, is I7. Okay, so you need to connect it to this one, PB0, this is a PB1, PB2, and the last one here go to your PB7. Okay, so here you can see. Okay, so this input here, input of the latch will connect it to your PB0 until PB7, and the second latch here as well will connect it to PB0 to PB7. Okay, next, the output of this latch, okay, you need to connect to your LEDs lah. Okay, for example, this one here, okay, the first latch is using the LEDs, and the second latch is using the 7-segment display. Okay, so you connect this one here to your latch, okay, LEDs. Okay, and the second latch is connected to the 7-segment. Okay, so now what happened here is port B now you increase the output from 8, okay, now connected to 16 output, which is 8 using the connected to 8 LEDs, while another 8 goes to the 7-segment, right? And then next is you need to look at here. This is the enable. Okay, so this enable here must be connected to either port lah. Okay, so let's say this is a PC0 and the second enable here connected to PC1, which is this one here is will control lah which latch that you're going to enable. Either you're going to send the data to latch 1 or send the data to latch 2 based on the value that you will give to PC0 and PC1. Okay, so for examples here, okay, now we're going to do a programming. Okay, so in this programming, okay, it's written in the assembly language, and you can translate, okay, this assembly language to C programming. Okay, no problem. Okay, first, what you're going to do, since port B, okay, need to make as an output port, okay, which is you need to connect it to these LEDs and 7-segments. So what you're going to do here is, okay, you need to initialize your port B so that your port B become output port. So how to do that? Okay, we started with int main void. Okay, And make sure that don't forget to include avr/io.h. Okay, so this is the standard file that you need. You are going to include every time you use input output device. Okay, so under this main program, first thing first that you're going to do here is initialize your input output port. How to initialize your input output port? By initialize it at your DDRX. Okay, in this case DDRB lah. Okay, so what will be the value? 0xFF. Okay, which is we're going to send one to the DDRB so that your port B become output port. So the D is the whole port B now become output. Okay, next, what you're going to do? Okay, after you initialize your port B become output ports, next, we need to prepare lah. Okay, we need to prepare what is the value that we're going to send to this LED. Okay, since this LED here, okay, for example lah, okay, you're going to do a sequence. Okay, you're going to send a value so that this LED, okay, this 4 LED turn on while this 4 LED is turned on. So how to do that? Okay, so depending on the common configuration used in this, okay, so in this case if you see here, so all of the, okay, so this one is wrong, because positive cannot connect to ground. Okay, suppose this one is a VCC, okay, and this is a negative. Okay, suppose this one here is a common anode. Okay, so please correct this one, must connect to VCC. So all the positive terminal must connect to VCC, cannot connect to ground. Okay, which is if you connect to ground, then what happen here is your LED will not turn on. All right. So let's we use a CA. So now we are going to turn on this LED, which is LED 0 until LED 3. So what you're going to do to turn on this LED is by send 0 or send 1 to this output of flash here. Is it send 0 or send 1? Common and to turn on. Okay, you need to give 0 lah. Okay, if you give 0, then the current can flow from VCC to your LED, through your LED, so that LED will turn on. All right, so here, okay, we'll port B. Okay, so this is the first lah value that you're going to put. Port B sama dengan OX. For example, now you're going to F0. Okay, so the first 4 LED will turn on and the last 4 LED will turn off. Okay, so this value here, where you're going to put okay, so this first value, where you're going to send the value, okay, you're going to send to this LED, not this 7 segment. So what you're going to do here is you need to enable. Okay, before that I forgot. Okay, sebelum tu, okay, you need to enable another one, DDRC, because DDRC now become our control unit. Okay, control to control this enable pin here. So make sure that the DDRC is initialized as an output port. Okay, so OX FF. Okay, port C sama dengan output to control the enable. Okay. Now, okay, port C. So what would be the value? Okay, since this one here you're going to send to the first slash dahulu. Okay, this slash 0, which is this one here is connected to PC0. So the value would be 0x. All right. Since this is at okay active flow, the enable is active flow, so you need to give 0, then the E is disabled. Or if you give 1, this E is disabled. At disable. Okay, so what you're going to do here is we're going to send kosong, 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 kosong. Or you can put this one is 111 pun tak apa. Alright. So 0010. Okay. So here PC0 enable, PC1 you are disabled. Okay. So now this value F0 will go to your LED. Okay. So the LED will turn on. What about the 7 segment? Since the 7 segment is disabled, so the 7 segment remain off. Okay. And then next, what you're going to do? Contoh lah. Okay. Now we are going to give this LED 7 segment here number 0. Okay. So this is a common catet. Okay. So you're going to display number 0 at 7 segment. So you need to prepare data. What is would be the data? A, B, C, D, E, F, G, and H. Okay, common catet. To turn on the LED, you need to give 1. Right? So you prepare the data to display number 0. What would be the data? A, B, C, D, E, F, G, and H. A turn on, B on, C also on, D, E, and F, while G and H turn off. So the data that you're going to send to this 7 segment is 3 F. All right. Okay, so now port B. Okay, so you prepare the data OX 3F. Okay, which is D is to display 0 at your 7 segment. Okay, assume that this 7 segment is common catet lah. All right. Next, port C. Okay, 0x0000. Since the 7 segment display is on this what we call here latch 1. So make sure that you enable your latch 1. So latch 1 put 0, while latch 0 you put 1. Okay, so here what happened here is, okay, so this is an enable and this one is disabled. Okay, so that's it. This is how you're going to expand the what we call the outputs by using the same ports. Okay, if you're going to expand this what we call here port B from 8 to 32, how to do that? Okay, you can expand this port B from 8 to 32 by using 4 latch. Okay, so you have a 4 latch, connected them to the outputs, and this one here, okay, the input of the latch is goes to this port B0 until port B7, and now you have 4 control unit, which is a PC0, PC1, 2, and 3 to control this latch here. Any question up until here? Ada soalan tak? Okay, next we have the bidirectional buffer. Okay, so this bidirectional buffer can be either input or output. Okay, so by using this bidirectional buffer, you can expand either an input port or an output port. Okay, and this one here used to control share data bus. All right, the chip that you can use for the bidirectional buffer is 74LS245. Okay, and last but not least is a keypad encoder. Okay, so this keypad encoder has both input push button and output to microprocessor. And this keypad encoder is used to read a keypad lah. Okay, you can press any value inside of the keypad, and that value, okay, will go straight to your microcontroller. So the IC for the keypad is MM74C922, and this is the keypad circuits. Okay, 1 pin enable, and this is the output from the keypad. Okay, so this is the input from the keypad. You press all the value inside the keypad and it will produce the output. This output here will be read by the microcontroller as a input from this keypad. And this is the truth table for the keypad. Okay. And this is how the keypad encoder works. Okay, so that's all for the input output. Any program for the input output? Any question? Do you have any question for the input output programming? Okay, if no question, okay, we will